Okay, section D is all about simultaneous equations. I don't want you to get bothered by some of the different terminology. You just got to get used to what they're talking about. Um, let's think of the opening problem. The cycle department of a toy store sells bicycles and tricycles. George notices there's 13 total cycles, and his brother counts 31 wheels. Is it possible to determine the number of bicycles and tricycles if we just look at George's observation or just James? Think of some different combinations just using George. So, like if there's 13 cycles, it could be one bicycle, 12 tricycles, or one tricycle, 12 bicycles. We could look at all the different combinations. What about James? Look at all the different ways we could come up with 31 wheels. But if we've got to consider both boys' observations to make each of them true, we're going to have to figure out which works for both. Can we do this without listing all possibilities? So probably one of the harder things about your IB tests is going to be reading a problem and getting a starting point. You might start off by doing one of these things and think, wait, there's an easier way. What do I need to do? So we have bicycles and tricycles. If there's a total, that means I'm going to add them together to get 13. How do we figure out the wheels? Well, how many wheels does B? Bicycles have 2 and tricycles have 3 to get 31 total. Now you see we have 2 equations with 2 variables. What are the different ways we've solved this in the past? We had a whole bunch last year, but there's 3 main ones that we're going to focus on. We graph, we substitute, and we eliminate. Those are the 3 main ways to solve a system. All right, so let's look at one example of each. All right, so first by graphing, notice this is in slope or gradient intercept. So I'm going to start with the y-intercept of -1, a slope of up 3, 1, 2, 3, over 1. And sometimes I'll do that multiple times to try and get the most accurate answer. All right, this is in general form, so I'm going to look at the intercepts. You can solve for y and use that way too. I'm just going to show you both. How do I find the x-intercept? I know that y equals 0 in the x-intercept, so if I replace y with 0, I get x equals 3. Then the same, how do I find the y-intercept? That's when the x equals 0, and then y equals 3. So I'm going to go ahead and plot my y-intercept, my x-intercept, and then when I connect my lines, and I should have arrows, where do they intersect? At the coordinate point 1, 2. Now, when you are solving any type of system, please make sure for each variable you have an answer. So when you graph it, you want that coordinate point listed as your final answer. All right, what about substitution? If in this system y equals x minus 3, that means each time you see a y, you can replace it with x minus 3. So I'm going to write down the other equation, but instead of y, I'm going to substitute x minus 3 in. First, we always need to distribute and get rid of our parentheses. Combine like terms on each side. Now I need to move the constant 9 over to the other side, so I'm going to add it to both sides. So I have my variable on one side, my constants on the other, divide by 5, and I get my x solution to be 5. Then I'm going to go back to my original equation of y equals x minus 3. And now I'm going to substitute 5. And I find my y solution of 2. So my final solution, I always like to write as a coordinate pair. And it addresses both my x answer and my y answer all at the same time. Now, if you have time, I always like to just double check. So I'm just going to check in my second equation. If I plug in 5 for x and 2 for y, I get 10 plus 6. Yep, that equals 16. So then it just kind of verified that it works for both equations. Okay, now we've got our elimination. The very first example is very straightforward. Literally, I'm going to, because another terminology for this, for elimination, is linear combination. Just means I'm combining, adding together like terms. So 5x plus 3x is 8x. Negative 2y plus 2y cancels out. It's eliminated to get 24. Solve for x. X is 3. Then I'm going to take my x solution, plug it back into either, because it's going to be the one answer that works for both equations. Now I'm going to solve for y. Then I write my final answer as my x answer and my y answer. Now, this was a very straightforward elimination because automatically they eliminate. Let's look at this one though. If I were to combine my variables, I'd get 5x plus y equals 9. That didn't eliminate either variable. So what I'm going to do, I want to make the coefficients opposite of each other, but the same numerical value. So notice the top equation is a positive y and the bottom one is a negative y. I'm going to multiply the top equation by 3 and the bottom equation by 4. And notice what happens when I distribute 3 through the top and 4 through the bottom. Now I can combine my equations and the y's are eliminated. That's our goal, to combine our equations together. So I'm left with one equation that has only one variable. Then I can solve for that variable. Then I'm going to go back to one of the original equations, replacing x with 2. Simplify. Subtract 6 from both sides. Write my final answer as 2, negative 1. And if you have time, go back and check your other equation. And if it makes both work, you know you've got the right answer. And I think that's done.